Hi, my name is Jim Winslow. I'm an old guy, 59 years old, wife, 4 kids, pretty darn successful career. My hobby is physics. I majored undergraduate electrical engineering, Lehigh University, Bethlehem, Pennsylvania. Got a master's degree from the University of Pennsylvania in electromagnetics and physics. Well, by the time I got out of UPenn, there wasn't much of an economy for that field, so I kind of ended up in software. But I kept thinking about physics, and I kept thinking, and I think I've got something that you'll be interested in. Here goes. Variable speed of light and gravitational lenses. Let's talk about what a gravitational lens is. Well, with a gravitational lens, a faraway object like a star, the light bends around a large massive object like the sun or a black hole. So what happens here, the star is actually here, and the light curves. When it reaches the observer, it's coming in a slightly different angle. And so you take the tangent of this curve, and that's where the star is observed to be. So here's its actual position and its observed position. This was predicted by Albert Einstein's theory of relativity. It's not initially accepted. Then they did an experiment. They waited for a solar eclipse. In the case of a solar eclipse, the moon would be in front of the sun, between the observer and the sun, and block out the sun, enabling them to point a telescope at the edge of the sun and see where the stars were. Well, they did that. It turned out to be true, and Einstein became even more famous than he already was. So let's interpret that. The interpretation is theory of relativity predicts that space and time are warped near large, massive objects, and this causes light rays to curve. So, in the vicinity of a large massive object, around near, space and time are warped. The closer you are, the more time and space is warped. And when you travel through it with light, you go on a curve. Well, pretty good explanation. But then, in the physics books, they say equations are too complicated to explain. Well, I set out to really understand this. The first thing I came up with was, well, gravitational lens, optical lens, what's the difference? So let me explain how an optical lens works. Optical lens, which is this, inside the lens, light travels slower than outside the lens. Now it doesn't actually travel slower, it just bounces around, and the net effect is that it's like it traveled slower. So, in the case of an optical lens, a faraway object, the light emanates in all directions from the faraway object, but when you're looking at it, it comes right at you, and you have a wavefront that is perpendicular to the direction of the light. So here's the original wavefront. By the time it gets through the lens, its wavefront is coming out as an angle. And here's a good way of thinking about it. Imagine a car here traveling fast, then slow, then fast, and a car here traveling fast, then slow, then fast, fast out here. This car is going to be ahead of this car once it comes out. This car ahead of that car because it has spent less time traveling slower. The net effect is that the wavefront is now at an angle. That causes the wavefront to direct towards the axis of the lens, and that's generally how a lens works. So I said, maybe that's the way a gravitational lens works. So here we go here. So here we have a gravitational lens. So if light travels slower near the large gravitational object than it is farther away, won't you get the same effect? So here we have an actual source. The light wavefront is coming in. It's traveling near the sun or the large massive object. Slightly lower speed. Okay? And as you go farther away, it has a slightly higher speed. The net effect is that the wavefront is bent, comes in a slightly different angle, and so the observed position of the star is different from the actual position, and it's due to the varying speed of light. two postulates. The spatial variation, speed of light. Postulate 1. Light speed is slower due to the proximity and magnitude of mass. In other words, the larger the mass, the closer you are, the slower the light speed. The further away you are from the mass, the higher the light speed. Postulate 2. The cause of gravitational lensing. Gravitational lensing is caused by the spatial variation of the speed of light. Let's compare this with Einstein's theory. Einstein and relativity. Space and time are warped. Causes light to curve. Complicated to explain. The Winslow theory, I gave it my own name, explained by classical electromagnetic field theory. Well understood, and it's very simple to explain. It is my honor for having you listen to me on this. Stay tuned for the next presentation where we relate gravity to the speed of light.